It just speared through the building like a fireball.
Everyone says the Twin Towers were destroyed by two planes, but the real story starts 30 years earlier, with a gamble. A gamble that many engineers quietly feared. A design so radical it rewrote skyscraper rules, and these two skyscrapers quickly became one of the boldest engineering gambles in modern history. Because the Twin Towers weren't just buildings. They were an experiment at a scale the world had never seen. And when you look closely, you start to wonder, were they symbols of confidence or warnings we didn't understand yet? Because the Twin Towers weren't just tall. They weren't just symbolic. They weren't even built the way skyscrapers were supposed to be built. They were lighter, thinner, more experimental. Two 110-story buildings that used less steel than many shorter towers. Exterior walls doing the work interior skeletons used to do. Floors hanging from trusses instead of resting on massive beams. If you told a structural engineer in 1950 that this would work, most would shake their head. Some actually did, but the buildings rose anyway. And once they stood, they didn't just change the skyline. They changed how engineers thought about height itself. Here's the part nobody talks about. The Twin Towers were not a conservative project. They were not cautious. They were not incremental. They were a leap. A leap funded by political ambition, driven by economic anxiety, protected by powerful institutions, and justified by the belief that America could engineer its way past any limit. So the real mystery isn't how they fell. The mystery is why they were built that way in the first place. Why leaders were willing to gamble billions on a design never tested at that scale. Why entire neighborhoods were erased to make room. Why engineers accepted risks they could only partially model. And most unsettling of all, if this design was such a breakthrough, why didn't the world copy it exactly afterward? Because when you look closely, the Twin Towers weren't just architecture. They were a statement about how much risk a society is willing to tolerate in the name of progress. And that statement began in a Manhattan that feared becoming irrelevant. Lower Manhattan today feels permanent, solid, unshakable. But in the late 1950s, it felt vulnerable. Corporate offices were drifting north. Midtown Manhattan was booming with sleek modern towers. Downtown buildings looked dated by comparison. Shipping patterns were shifting. Containerization was changing ports. New Jersey was gaining economic ground. For the first time in decades, New York's financial heart didn't feel guaranteed, and powerful people notice when power starts to slip. David Rockefeller noticed. As chairman of Chase Manhattan Bank, he had both influence and motive. He believed Lower Manhattan needed a dramatic revival. Something bold enough to pull global commerce back downtown. Not a renovation, not a facelift, a transformation. The idea of a World Trade Center began as a practical concept, a hub for international trade organizations, import-export firms, global business offices, reasonable, functional, contained. But megaprojects rarely stay modest, because modest projects don't create legacy, and legacy mattered. Enter the Port Authority of New York and New Jersey, a bi-state agency with unusual power. It could issue bonds, control infrastructure, operate with political insulation. In other words, it could do things normal city agencies couldn't. And within the Port Authority was Austin J. Tobin, a man known for confidence and scale, a man who believed big projects defined eras. Under his influence, the numbers grew. More square footage, more height, more presence. The World Trade Center wasn't going to be a complex. It was going to be the largest office development on Earth. That shift changed everything, because size multiplies stakes, size multiplies cost, size multiplies risk, size multiplies consequence. Then came the site selection. And this is where the story stops being abstract. The chosen land wasn't vacant. It was alive. Radio Row, a dense commercial district filled with electronics shops, repair stores, warehouses, and suppliers. Walk its streets in the early 1960s and you'd hear radios playing, salesmen bargaining, technicians testing components. It was noisy, busy, human, hundreds of businesses, thousands of workers, decades of relationships. And all of it sat exactly where planners wanted their mega project. To planners, it was real estate. To owners, it was life. Protests followed. Legal challenges followed. Shop owners organized. Some believed the courts would protect them. For a moment, a ruling even suggested the project lacked sufficient public purpose. But power has momentum. Appeals overturned decisions. Higher courts declined involvement. And once demolition started, resistance became symbolic. Entire blocks were razed. Think about that for a moment. Before the Twin Towers rose as symbols of global commerce, they began as the removal of local commerce, progress for some, loss for others. And here's the quiet tension. When a project requires this much force just to begin, it creates pressure to succeed at any cost. Because failure would mean the displacement wasn't worth it, and that pressure doesn't disappear when construction begins. It grows. By the time the first shovel hit the ground, the towers already carried political weight, economic weight, and human weight. Turning back wasn't an option. The only direction left was up. Once demolition cleared the site, the Twin Towers stopped being an idea and became a race against cost, a race against doubt, a race against time. Because megaprojects don't live in theory. They live in schedules and budgets, and every delay translated into millions of dollars. Construction officially began in 1966. Almost immediately, the challenges stacked up. The site itself fought back first. The towers were being built near the Hudson River on landfill and soft soil, not ideal ground for the heaviest buildings on Earth. So engineers had to build what they called the bathtub, a massive slurry wall system dug deep into bedrock, forming a watertight box around the site. Imagine digging a giant hole beside a river and trusting a wall of slurry and concrete to hold the water back. It had to work. If it failed, the Hudson could flood the site and cripple the project. This wasn't just clever engineering. It was necessity, and the pressure on workers was immense. Hundreds of laborers rotated through the site daily. Iron workers walked beams hundreds of feet above ground, sometimes with wind whipping through unfinished floors. Photographs from the era show men eating lunch on steel beams, legs dangling over open air. To the public, those images looked heroic. To the workers, it was just the job. But it was a dangerous job. Falls were a constant risk. Heavy materials swung on cranes like pendulums. One slip could be fatal. Yet many workers felt pride. They weren't just building offices. They were building the tallest structures in the world. There's a powerful psychology in that. When people believe they're part of history, they tolerate risks differently. And still, tension simmered beneath the surface. Labor disputes occasionally slowed progress. Union negotiations shaped schedules. Contractors pushed for efficiency. Every megaproject has quiet friction. The Twin Towers had it at massive scale. Then there were the engineers. Today we rely on advanced computer simulations. In the 1960s, modeling was limited. Engineers ran calculations, wind tunnel tests, and theoretical models. But they didn't have decades of tube structure skyscraper data, because this hadn't been done before. Leslie Robertson and his team weren't reckless. They were methodical pioneers. But pioneering means walking into the unknown with math as your flashlight. And math, while powerful, isn't prophecy. Every decision carried weight. How thin could steel be? How much sway was acceptable? How would occupants feel movement? Because engineering doesn't just manage physics, it manages human comfort. A building can be safe but still feel unsettling, and perception matters. Minoru Yamasaki understood that. His design choices weren't only structural, they were psychological. He favored narrow windows partly to reduce vertigo at high elevations. Think about that. Millions of future occupants would experience height through the lens of one architect's sensitivity to it. That's how human megaprojects really are. They're not purely rational. They're shaped by personalities, fears, ambitions, and compromises. Here's the pattern interrupt. The Twin Towers were not designed by a machine. They were designed by people navigating uncertainty. And people don't always agree. Some architects criticize the towers as too stark, too impersonal, too monumental. Some planners worried about concentrating so much office space in one area. What if tenants didn't come? That question haunted early projections. Because filling 10 million square feet is no small task. It requires demand, growth, and timing. And timing is something no architect controls. Still, the project moved forward, because stopping would signal doubt, and doubt is expensive in politics. By the late 1960s, the towers began rising visibly. Steel climbed into the sky. The skyline changed month by month. New Yorkers watched, some with awe, some with skepticism. And inside the project, one quiet truth settled in. There was no turning back. Too much money committed, too much reputation invested, too much momentum built. The only path was completion. But finishing the towers would reveal a new kind of conflict. Not structural, not political, but economic. Because building something extraordinary doesn't guarantee people need it. And the next phase would test that reality. By the time the steel began rising above street level, The Twin Towers were already defying convention. But from an engineering perspective, the real experiment was just beginning. Because up to that point, most skyscrapers followed a familiar formula: heavy interior skeleton, dense forest of steel columns, exterior walls acting like skin, not bone. The Twin Towers flipped that logic inside out. Instead of hiding strength inside, engineers pushed strength to the perimeter. They created what became known as the tube-in-tube system. Picture a hollow steel rectangle rising into the sky. Each tower had 236 closely spaced steel columns along the exterior. They were connected by deep spandrel plates, forming a rigid lattice. This outer grid acted like a giant vertical tube. It resisted gravity. It resisted wind. It carried enormous loads downward. Inside the tower sat the central core, a rectangular cluster of elevators, stairs, and mechanical systems. That core formed a second tube, between the outer tube and the inner core. Wide open floors, no columns interrupting the space, an entire acre of uninterrupted office floor per level, repeated 110 times. For tenants, this was revolutionary. You could design offices however you wanted. No awkward columns blocking layouts. For developers, it meant maximum rentable space. For engineers, it meant distributing forces in ways rarely attempted before. Here's the twist. The windows were not just windows. They were part of the structure. In most skyscrapers, you could remove the facade and the skeleton would stand. In the Twin Towers, the facade was the skeleton. Those narrow vertical window bands weren't only aesthetic. They existed because steel columns had to be closely spaced to make the tube strong enough. Beauty followed engineering, not the other way around. Then came the real giant: wind. Wind becomes exponentially more powerful with height. At 1,300 plus feet, it doesn't just push, it tests. Designers calculated that the towers could sway several feet in strong winds. That number startled some people. But sway isn't failure. Sway is survival. A rigid skyscraper that tall could crack under stress. A flexible one bends and dissipates energy. Still, human perception complicates physics. People feel movement long before it becomes dangerous, so engineers added viscoelastic dampers, materials that absorbed and reduced motion. Early energy dissipation technology, cutting edge for the era. On stormy days, some occupants still reported gentle movement, a subtle sway, like being on a ship, safe, but psychologically memorable. And psychology matters in tall buildings. A structure can be perfectly sound, but still unsettle the people inside. Now consider the elevators. A traditional elevator system wouldn't work at this height. Cables would be too long, trips would be too slow, core space would be consumed by shafts. So engineers borrowed an idea from transit systems. They created sky lobbies. Express elevators carried people to transfer floors. From there, local elevators served zones, like a subway system turned vertical. This allowed fewer shafts, more usable space, higher efficiency. It also introduced complexity, more systems, more coordination, more points where precision mattered. Construction itself became choreography. Steel sections arrived prefabricated. Crane lifts required exact timing. Alignment tolerances were tight. A small error on one floor could magnify over dozens of floors. Millimeters mattered. Crews developed new techniques on the fly. They weren't following a playbook. They were writing it. And here's the emotional pivot. For a long time, nobody truly knew if the concept would perform exactly as predicted. Yes, the math worked. Yes, the models suggested stability. But this scale was unprecedented. It's one thing to test theory. It's another to live inside it at 100 stories. Every rising floor was a quiet vote of confidence. Every successful alignment built belief. Slowly, the impossible started to feel possible. Then, inevitable. By the early 1970s, both towers pierced the skyline. New Yorkers looked up and saw something surreal. Twin monoliths, minimalist, massive, unignorable. They weren't ornate like older towers. They were modern, corporate, global. Some loved them. Some thought they were too stark. But nobody ignored them. And within the engineering world, a realization spread. The experiment worked. The towers stood. They swayed as designed. They carried their loads. They proved you could rethink skyscraper structure entirely. But success created a new question. Just because you can build something, should you always build it at maximum scale? Because now, the challenge shifted away from physics. The towers were about to face something math couldn't solve: market reality. When the Twin Towers were completed, the expectation was simple. Tenants would rush in. prestige would follow. Lower Manhattan would be reborn. That's how megaproject stories are supposed to go. But reality rarely follows the script. When the North Tower opened in 1970, New York City was entering economic turbulence. The city was losing manufacturing jobs, budgets were tightening, corporate expansion slowed, and suddenly, the world's largest office complex opened into a soft market. Floor after floor sat empty. Imagine the optics, the tallest buildings on Earth, and large sections unleased. The Port Authority faced quiet embarrassment. This wasn't supposed to happen. They had built scale ahead of demand, assuming demand would rise to meet it. Sometimes that works, sometimes it doesn't. At first it didn't, so the Port Authority became its own tenant. Government agencies filled space, public offices moved in, state departments occupied floors meant for international commerce. Critics seized on it, newspapers questioned the economics, commentators called the towers oversized. Some labeled them white elephants, magnificent to look at, hard to justify financially. Here's the pattern interrupt. The Twin Towers succeeded as engineering, but struggled as real estate. That reversal caught many off guard, because we assume bold projects bring instant payoff. In reality, payoff often lags behind vision. Still, time works differently for landmarks. Gradually, the towers found their footing. Major firms began signing leases. Financial institutions valued the prestige address. The location gained symbolic weight, and symbols attract tenants. Then came culture. Observation decks drew tourists. Visitors lined up to see the city from unmatched height. Windows on the World, the restaurant atop the North Tower, became one of the highest-grossing restaurants in the country. People celebrated birthdays there, anniversaries, business deals. Life moved in. And that's the turning point for any building, when it stops being a project and starts being part of memory. By the 1980s and 1990s, the towers weren't controversial. They were familiar. They appeared in movies, postcards, news broadcasts. They became shorthand for New York itself. Mini payoff moment. The same buildings once doubted became identity markers. That transformation is powerful, because public perception often defines success more than spreadsheets. And quietly, the engineering world absorbed the lessons. Tube structures influenced future skyscrapers. Open floor plans became desirable. Lightweight structural thinking spread. The Twin Towers changed the profession. But here's the subtle twist most people miss. No one replicated the exact formula. Modern supertalls use more steel, not less. They include more redundancy, more backup systems, more conservative margins. It's as if the industry said, yes, it worked, but let's not push that far again. Success revealed the edge of possibility, and engineers tend to step slightly back from edges, because the goal isn't just to stand, it's to endure uncertainty. And uncertainty always exists. The towers had proven a concept. They had reshaped design philosophy, but they also showed that pushing limits carries invisible trade-offs. Trade-offs that don't always appear immediately, and history has a way of revealing trade-offs slowly, sometimes decades later, which leads to the final reflection. Not about steel, not about height, but about how societies choose to build their future. The Twin Towers left behind more than a skyline gap. They left behind a question about how humanity builds, why it builds, and how far it should go when chasing the future. Because the towers were born in a very specific era. The 1960s believed in big leaps. The moon landing wasn't a dream. It was a schedule. Supersonic jets weren't fantasy. They were prototypes. Mega dams, mega bridges, mega cities. All symbols of confidence. If something looked impossible, the response wasn't caution. It was momentum. The Twin Towers came from that mindset. They weren't designed to be modest. They were designed to be definitive. Proof that American engineering could outrun limits. Proof that political will could bend logistics. Proof that scale itself was power. And for a time, that belief felt justified. The towers stood. They performed. They influenced skyscrapers worldwide. They proved that rules weren't fixed. They were starting points. But progress always runs into a quiet truth. Every generation believes its technology has mastered risk. History repeatedly humbles that belief. Not because engineers are careless, not because designers are reckless, but because the future introduces variables no blueprint can fully predict. The Twin Towers were designed for the future people imagined in the 1960s, a future of economic growth, commercial expansion, global trade. They were not designed for the world that eventually emerged, and that gap between imagined futures and real ones is where vulnerability lives. Here's a deeper thought. Skyscrapers are time capsules. They record what a society values, what it fears, what it believes is possible. The Twin Towers recorded optimism. They captured a moment when humanity trusted progress to solve problems faster than problems could appear. But after 2001, something shifted. Building codes evolved. Safety philosophy changed. Redundancy became a priority. Evacuation design became central. Modern super tools include more stairwells, stronger fireproofing, wider exits, compartmentalized systems, not because engineers became less capable, but because the definition of acceptable risk changed. That's an important distinction. Engineering doesn't just follow physics, it follows culture. And culture decides how bold is too bold. Some people see that shift as wisdom, learning from history, protecting life. Others see it as caution overtaking ambition, optimization replacing invention. Neither view is entirely wrong, because progress is a balancing act. Push too far and you risk failure. Play too safe and you risk stagnation. The Twin Towers sat right at that intersection. They were bold enough to change the industry, but bold enough to make people reconsider how far boldness should go. And that's why their story still matters. Not because they were tall, not because they were famous, but because they forced a conversation about how humanity pursues the future. Here's the unresolved loop. What kind of world do we want to build next? One driven by daring leaps, or one guided by careful steps? If a project today promised tens of thousands of jobs, global prestige, a record-breaking skyline, economic revival, but included unknown risks, would you support it? Would you vote for it? Fund it? Defend it? Or would you slow it down? So now the question turns to you. Do we build safer today, or do we just build less boldly? Should humanity still pursue megaprojects that push limits? Or is the age of bold experiments over? Because the skyline of tomorrow is shaped by what people are willing to approve today, and whether we realize it or not. We are all voting on the future with our opinions, our policies, and our priorities. The Twin Towers asked the world a question. We're still answering it, and maybe we always will be. If you made it this far, you're clearly someone who enjoys deep dives like this. So here's the deal. This channel is built for curious minds who like stories behind the headlines, the engineering behind the icons, and the history that most people miss. If that sounds like you, consider subscribing. Not for me, but so you don't miss the next story. If this video made you think, share it with someone who'd enjoy the conversation too. These topics get more interesting when more people are part of them. And I genuinely love your input. What should we explore next? Drop your ideas in the comments. I read them, and many videos start there. Thanks for spending your time here. That's the one thing you can't get back, and I don't take it lightly. See you in the next one.